In this video, we will look at the weight of the V parameters and how they can be analyzed and used. We will also discuss how different characteristics affect the search for algorithms. First, let's deal with the weight. In previous videos, we learned that each algorithm consists of parameters, and the same parameter can be present in different algorithms. This means that we can count how many times a particular parameter is used in different algorithms. The weight of a parameter determines the number of algorithms in which it is present. Let's move on to the drawing that describes this technology. We can see that arrows go from each parameter to the algorithms where it is present. However, different parameters may have different numbers of arrows. You may also notice that there are parameters that are not present in any algorithm. If you compare this scheme with neural networks, you can immediately see the differences. In neural networks, each input is associated with each neuron, and the weight is a characteristic that is used for calculations within the neuron. Let's look at the results of algorithm analysis. You can see a table where the first column shows the parameter number, and the second column shows the number of algorithms in which this parameter is present, that is its weight. The table is sorted in descending order of weights. The weight value for this parameter may vary depending on which algorithm package is being analyzed. We see parameters with large weights, which means that they have a high value in algorithms. The lower the weight, the lower the value of the parameter, and as a result, we get to parameters that are not present in any algorithm at all. Their weight is 0, and using such parameters does not make sense. Thus, by analyzing the parameter weight, we can exclude those that are not present in the algorithms. Now let's look at what and how different settings and the number of parameters affect when searching for algorithms. For the study, we will take two tables with data collected in the same objects. The difference between the tables is in the number of parameters. The first table has 256 parameters, while the second table has 503 parameters. We will look for patterns with the same settings. Let's take a look at the results. We see that the more parameters we examine, the more algorithms we find. If you increase the number of parameters almost twice, the number of algorithms found will increase several times. However, the search time will also increase significantly. Now let's look at how the number of positive bids in the algorithm affects the number of algorithms found. We analyze the same statistics. The search parameters of the algorithms are also identical, except for the minimum number of positive bids. In the first case, the minimum number of positive bids in the algorithm is 6, in the second, 8. As you can see, the fewer bids that can be placed in an algorithm, the more algorithms we will find. Let's look at how the maximum percentage of losses in an algorithm affects the number of algorithms found. In the first case, the gain in each algorithm should be in the range from 85 to 100%, and in the second case from 90 to 100%. The narrower the range, the fewer algorithms will be found. In this video, we looked at how different characteristics affect the number of algorithms found.